Hey CS mate, how should I write my code? Honestly, everyone has their own way of doing things, but here's what works best for me. First, here we go. I like to plan the project. Say I'm implementing a class or something, I might plan things as they would build upon each other. So, for example, say I'm writing a class like we said. First, I might write the constructors, then the getters, then the setters, because the setters might change the, the what is it, like the structure of the class depending on what kind of class you have. Like for example, if you're implementing like a binary search tree and you set it to an AVL tree instead of like a just like a normal binary search tree or a splay tree. And then I might write class specific functions like insertions, then searches, then lastly deletions, and finally the destructor or destructors. Some people might have issue with this. I've heard some people say, oh, write your destructors like with your constructor, but I think once you actually create your function and you can create the rest of its functionality, I think it's a lot easier to write your destructor because you just you're more familiar with your code and how it's gonna work. But yeah, so like I said, I plan. I say this is how I'm going to create these functions because you want it to naturally build upon each other. You don't want to just, write the search before anything else because, if you don't have anything constructed, how do you test it, right? And if you implement things out of order or in an order that doesn't make sense, you're likely going to have to go back and redo it. So I think planning it in a way that makes sense, that is incremental, saves time. All right, let's change to a different color so it's a little bit more interesting to look at. So yeah, and after that is the implementation process. So as you can see, this is a 3-step process, but some of it kind of happens at the same time. So I'll explain. But yeah, here's the process: writing and commenting, all right, writing your tests, and then testing. So when I'm implementing something, I think it helps to think about how you will test as you write the function. The reason this is useful is because if you are writing a function that's pretty inefficient and you're writing in a very strange way, if you do that and say it works, and then you have to go back and test it, and it's like, if it's hard for you to even understand, or it doesn't make sense the way you implemented it, it's going to be significantly harder to test it. So if you're writing your functions with how you're going to test it in mind, I think it's a lot easier to test those functions, and also to get like accurate tests and then good working solid functions. So that way too, as you're writing those functions, if you're considering how you're going to test it, can kind of help guide how you write the function. So yeah, so as I'm working on the implementation, I think it's important to write the comments at the same time. So if I'm just writing code, blah 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 blah, right, and then I'm like, all right, I'm gonna go back and write comments like on top of it, that's fine. However, and I've seen a lot of people do it that way. However, if before you write your code, you make a comment, i.e., you have an idea in your mind about how you're going to write the code. So it's going to be something like this, right? You write your comment first, explaining it. Here. You write your comment first, explaining the code. It's going to allow for you to have a much more solid thought process as you're writing your code. So it just thinking about how your code is going to work and thinking about how you're going to implement it and describing that in your language of choice, in terms of like your spoken language, it helps you, again, it helps you solidify your understanding and it helps you write more efficient code. If you can't even describe it to yourself before writing it out, then the question I would ask is, do you really understand what you're doing? And if you don't understand what you're doing and you write like comments that don't really make sense, well, if you're working on a team and you're in a software development situation, and you know you're passing off your code to someone else and they have to write on top of your code, if you can't even understand it, how are they going to understand it? So again, all of this really is about just solidifying your thinking and being intentional with your writing of code. All right. So after the implementation is complete, after you're done writing and you're doing your comments at the same time and planning your tests at the same time, then you write your tests. So, if first, obviously you want to make sure the code compiles. If it doesn't compile, then you might have some syntax issues. But obviously that's only if it's in a compiled language. Something like Python, you don't really have to worry about that, because Python will just run correctly until you hit whatever line the error is in. But yeah. Anyway, after you're done compiling, you want to write your unit tests. It's good practice to have a test file that has the following. One, tester class. And then the tester class has to have functions which are your unit tests that test normal, edge, and error cases of your original function, right? So that's in your your other file, your .cpp file or your header file, or that's defined in your header file, I should say, or declared, I should say, actually. So doing it like this, keeps everything clean, because you don't really need to submit a test file to anyone. However, if you have a tester file, it's just good practice, and you can say to your employers, like, this is how I implement my code. I use tester files, blah, 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 and I don't know. It just looks nice. You want to be able to test, not just, all right, I'm going to put, a print statement in my function, or I'm going to put like a cout statement in my function to see if it actually runs through every line. Using actual test functions to test your code really makes it so that you have a lot more confidence in your code, and that you're sure it will work right. But obviously that's dependent on you writing good tests. If you're working with a linked list and you want to know, all right, say it's like ordered by, you order your linked list somehow by like the data, right? Your linked list could look like this, and you could say, well, I know I inserted 1 in my test file, and inserted 1, 2, 3, 4, so I assume it should be in the correct order. So I'm going to test that the the head of the linked list is 1, and if it's 1, test passes. Well, guess what? As we can see, it's not actually in the correct order, and it isn't how we want it to be. So that's why you have to write tests that test every aspect of your code, of your function, or your implementation, so that you know what's actually right. And again, for a test file in your tester classes, you should test everything. So for your test file, you'd have, and this is a little, this is very thorough, but in your test file, you would have a test case for your constructor, normal, edge, error case, and you would have the same thing for your getters, your setters, your insertions, your searches, your deletions, and your destructors. And having it like this means you're going to catch a lot of different things. Like, there's been so many times where I've been writing code and it works great on my normal and edge case. So I'm like, what's an error case? And I, try and insert something empty or something like that, right? And all of a sudden, it breaks. So that tells me, all right, I got to go fix my initial code, right? And that was because my tester file helped me illustrate issues with my code. So again, like, this really is just about illustrating clear thinking, and just, taking steps to make sure you're doing things right. And after you make these tests, and if they actually execute and your code is good and your test passes, you'll have a lot of confidence in your code, and if it fails, you'll have a chance to improve it instead of just having like weak tests that don't show anything. So this process, and then lastly, so again, you test it, and then after that, you repeat the process. You go back to your planning, your writing and commenting, your writing tests, and then your tests. If you plan everything you're going to do, you could probably just go straight to writing and commenting. That's kind of what I do. But if you're like, all right, I'm just going to do one thing at a time, I'm going to start with insertions, then, you might plan your tests, plan what you're going to write, plan, how it's going to work. Then you go through it all, and then you go back to the drawing board and plan constructors, and then you plan this and you plan that. So it really just depends. But personally, I like this method of planning, then implementation, and then planning, and then implementation. And inside of implementation, you have your writing, your comments, your tests, and then executing your tests. In software development, there's several different ways of implementing code, like what we have: waterfall, agile, scrum, Kanban, DevOps, etc. But this method can be implemented in any of these methods. This is just a personal idea of how to write good, solid, clean code that you can be proud of. So hopefully this was helpful. Let me know if you have any questions. Definitely be sure to like and subscribe. Thank you.